Good day, everyone. My name is Julina Puyod. Today, I will be discussing to you another topic in measurements, which is micrometer. This is under the adjustable measuring tools. Introduction to micrometer. Micro is a unit's prefix in a metric system, denoting a factor of 10 to the power of negative 6. Confirmed in 1960, the prefix comes from the Greek meaning small. The symbol for the prefix is the Greek letter U. Meter is the base unit of length in the International System of Units. The SI unit symbol is M. The meter is currently defined as the length of the path traveled by light in a vacuum in 1 over 299,792,458 of a second. So now class, before we continue to our discussion, I have here a question to you about what is a micrometer? Do you have any idea? Anyone from the group? Okay, so if none, then let's proceed. Micrometers, or otherwise known as micrometer screw gauges, are essential measurement tools used by mechanical engineers, machinists, and workers in other technical trades. They enable workers to take extremely fine measurements, which may be displayed in either imperial or metric formats. Micrometers allow for a greater degree of measuring accuracy than alternative tools, such as dial calipers and vernier calipers. They are available in digital, dial, and vernier styles. The term micrometer can be traced back to neoclassical Greece and literally translate as small measure. Different types of micrometers have measuring ranges of between 25 mm and 1 inch. This translates to the incremental metric measurements of 0 to 25 mm, 25 to 50 mm, 50 to 75 mm, and so on. The imperial versions are equal to 0 to 1 inch, 1 to 2 inches, 2 to 3 inches, and etc. Boxed micrometer sets can also be used for the purpose of taking micrometer readings across a wide range of sizes. So, class, this is a micrometer looks like. It is an instrument for making precise linear measurements of dimensions, such as diameters, thicknesses, and lengths of solid bodies. It consists of a C-shaped frame with a movable jaw operated by an integral screw. Micrometers are usually, but not always, in the form of calipers, opposing ends joined by a frame. The spindle is a very accurately machined screw, and the object to be measured is placed between the spindle and the anvil. The spindle is moved by turning the ratchet knob or a thimble until the object to be measured is lightly touched by both the spindle and the anvil. Micrometers are also used in telescopes or microscopes to measure the apparent diameter of celestial bodies or microscopic objects. The micrometer used with a telescope was invented about 1638 by William Gascoigne, an English astronomer. So class, he is William Gascoigne. He was the inventor of the telescopic sight and micrometer. or instruments crucial to the advance of astronomy. His name is now known to historians around the world. For some considerable time after his tragic death at the age of 32 in the English Civil War, however, it seemed as if his achievements would be consigned to oblivion. Most of his papers were lost, and even the few that survive have largely disappeared. This is the story of how his work was rescued. Into this story is woven an account of the state of astronomy and optics during Gascoigne's lifetime, so that the reader can appreciate the significance of his discoveries. So now let us move to the parts and function of a micrometer. First, we have to start the parts of micrometer. The zero adjust screw, the anvil, the spindle, the lock nut, the sleeve, the knurled gripe, the ratchet, the thimble, and we have here class the C-frame. So class the anvil and spindle faces. So now we have to move the functions of its parts. So C-frame is a C-shaped frame as identified in the picture. Is a rigid part that has both holding points for a job or object to be measured. Its size depends on micrometer measuring range. So size of a C-frame increases as range expands to bigger. And its main function is to provide basic structure of a micrometer in which stationary anvil located at one end and movable spindle slides inward or outward through other end of C-frame. Zero adjust screw. It's a screw located back end of anvil shown in figure. As name shows, it is to correct or adjust the zero error of micrometer. If there is some error found before the measurement during test. Anvil. As discussed above, it is a small cylindrical part of micrometer located in far end of C-frame and acts as one holding point for measuring objects. So we can say that it's a one of rigid measuring and holding point of micrometer. Spindle. A cylindrical long part which is mounted through all other parts, sleeve, lock nut, and thimble. It is movable part and has a connection with ratchet as we rotate the ratchet clockwise or counterclockwise. The spindle slides out or inward to adjust it with compared to measuring object size. Anvil face and spindle face. Faces of both anvil and spindle, which are opposite to each other, are the measuring points of micrometer and holding the measuring object collectively. Lock nut. As we know, the mechanism of micrometer based on precision ground threads of spindle, so the lock nut works as stationary nut. For this mechanism, so rotation of this mechanism into lock nut controls the spindle movement. Slave or sleeve. It's a barrel type cylindrical part which mounted on spindle and its main scale of micrometer because main scale is engraved on the sleeve. Thimble rotates around that sleeve and spindle. Its main function is to indication of reading in millimeter in case of imperial micrometer. Thimble. Thimble is also mounted on spindle and a scale is engraved around it. Perimeter or perimeter of a thimble. Scale of thimble is to show the measurement value in fraction. Ratchet is a knurled thumb grip to rotate the spindle into desired direction. For measuring process, provided with ratchet action to avoid over-tightening of micrometer across the measuring object. It also ensures equal pressure force of each measurement. So now class, before we continue to our discussion about the metric reading, we have to um, we have to watch first the video regarding on how we are going to use a micrometer since it is new to us.
Right, this is a micrometer. It's used for measuring your parts very precisely. Its precision usually is 1/100th of a millimeter, and they come in 25 millimeter increments, meaning that this frame varies and the travel is always 25 millimeters. So this particular model measures from 0 to 25 millimeters. So let's now have a quick look at how the micrometer is built, and then we're gonna have a look at how to measure with the micrometer. Right, so this still is our 0 to 25 millimeter micrometer, and it consists of several parts. This is the frame, as we talked about. This varies from micrometer to micrometer depending on its size. Then we've got our anvil, which is the static part here, and our spindle, which is this part that moves back and forth. And here we can see a locking nut, which is used to lock our dimension. And then we can rotate with a thimble here, which has our graduation that shows us the hundredth and tenth of a millimeter. Then our sleeve here has a graduation also, and it shows us the whole millimeters and half millimeters as well. At the end of the thimble here is a ratchet, which ensures that we always use the same force when measuring a part. If we screw the thimble all the way back, we actually can take it apart and see our micrometric thread inside. You can see a micrometric thread here. This is a crucial part of the device, and it's precisely ground fine thread. It has 0.5 millimeter pitch. So when I rotate the thimble 360 degrees, the measuring face advances 0.5 millimeters, and that's why this graduation here is divided in 50 pieces. And one of the reasons why those micrometers come in 25 millimeter increments is this fine thread, because to make such a precise and fine thread over a long distance is not so easy, and therefore it's very expensive, firstly, and secondly, so that you only have to rotate 25 millimeters back and forth, because otherwise you would just be threading your spindle whole day, and that's no fun. Right, when we are here we can see the measuring face as well. We've got two measuring faces, and this is the most basic one. There are different ones especially made for measuring threads or gears, for example, but this is the most basic one and probably the one you are going to come into contact with. And sometimes the faces are made from different material, which is a little bit more wear resistant. This particular one has the same material, but I have 25 to 50 millimeter example here, which has a different material on the measuring face. Hopefully you can see it a little bit on the camera. So those are the most basic stuff you need to know about micrometers, and we can now have a look at how to measure with a micrometer. So I've got a part here and I just want to know how thick it is. So to measure it precisely, I'm gonna take my micrometer and I'm gonna bring it very close. When I'm close, I'm going to use this ratchet, which ensures the force is going to be the same all the time. And I'm just going to rotate it like 2 or 3 times. Then I'm going to lock it with the locking nut, and now I can take a measurement. Firstly, we are going to have a look at this linear graduation here, and we are going to look at the top lines right here, which show us the full millimeters. So I can see 4 of them here, and the bottom ones shows us half millimeters. So when you can see the half millimeter mark, you know that you are at 4 whole millimeters and somewhere between 4.0 and 4.5. And to see where, you're gonna look at this graduation on the trimble and just have a look at where it lines up with this zero line here. So as you can see, mine lines up at 29, so I know I'm at 4.29 millimeters right now for this part. Pretty straightforward. You just have to be a little bit careful with those half millimeter marks and yeah, just to look properly. Now I know what micrometer is, how it works, and how to measure with it, hopefully. As you can see, it's pretty straightforward once you get a hold of it. And what I like to do to mitigate any errors is to take a measurement with calipers first to see what kind of dimensions I'm aiming for, and then take a precise measurement with my micrometer. Alright, I hope this video was helpful, and I'm gonna see you next time. Bye!
Okay, class. So another video, and please study. Okay, class. So now we're done on watching those videos. So we have to continue our discussion about the metric reading of a micrometer. Inspection method, metric measurement. The metric micrometer looks very similar to a standard inch micrometer until you look at the graduations on the sleeve and the barrel on figure 1. So this is the figure 1, 0 to 25 millimeter micrometer. These are two separate rows of lines on the sleeve of the metric micrometer. So in figure 2, this is the figure 2 class. When reading a metric micrometer, you have to remember to add the half millimeter graduations of the upper row to the reading. The lower row represents whole millimeters graduation. The upper row represents 1/2 millimeter. Each complete turn of the thimble moves the spindle 1/2 millimeter or 0 to 0.5 mm. The circumference of the thimble is separated into 50 equal dimensions or divisions, in figure 2 or zero point zero 0.01 mm. Reading the metric micrometer. To read the metric micrometer, first read the number of the whole millimeters on the bottom row of the sleeve of the micrometer in figure 3. These are the whole millimeters. If there is an additional line uncovered on the top row, this is equal to 1/2 a millimeter in figure 3. So 0.5 mm would need to be added to the measurement. Then add the thimble reading to whole and a half millimeter sleeve readings. Refer to figure 3, 4, and 5 and try to read the measurements before looking at the answers in the figure explanation. 23 whole divisions are uncovered is equal to 23 millimeters. 0 millimeters divisions are uncovered is equal to 0.0 millimeters. 15 to 0.01 millimeter divisions line up on the thimble is equal to 0.15 millimeters. So in this figure 3, the metric micrometer reading equals 23.15 millimeters. 18 whole divisions are uncovered is equal to 18 millimeters. 0.5 millimeters division is uncovered is equal to 0.5 millimeters. 10.001 10 to 0.01 millimeter divisions line up on thimble is equal to 0.10 millimeters. So in this figure 4a, the metric micrometer reading equals 18.60 millimeters. 15 whole divisions are uncovered is equal to 15 millimeters. 1 to 0.50 millimeters division is uncovered is equal to 0.5 millimeters. 13 to 0.01 millimeter divisions line up on the thimble is equal to 0.13 millimeters. So in this figure 4b, the metric micrometer reading equals 16.63 millimeters. Note, some manufacturers of micrometers may reverse the position of the whole and the half millimeter graduations. The order in which you read the micrometers will still remain the same. Example, the whole millimeters, half millimeters, and hundredths of a millimeters. So let's proceed to the example of the metric reading of a micrometer. So first we have to read the upper part of a micrometer and let's proceed to the lower part and then the right side. So 25 mm plus 0.50 mm. So the total reading for this example is 25.50 mm. Example number 2. 26 mm plus 0.36 mm is equal to 26.36 mm. Example number 3. 26 mm plus 0.50 mm is equal to 26.50 mm. And last example, 42 mm plus 0.50 mm plus 37 mm is equal to 42.87 mm. So the total reading for this example is 42.87 mm. Okay, class. So now we're done on reading the metric micrometer. And now let's proceed to the vernier micrometer reading. Reading the vernier metric micrometer. The vernier metric micrometer has the ability to measure to 2000 of a millimeter or 0.002 mm. 0.002 mm is equivalent to approximately 0.00008 of an inch. The vernier is graduated in increments of 0.002 mm, starting and ending with 0 in figure 5. If either 0 on the vernier graduation scale lines up with the thimble reading, no additional thousands of a millimeter are added to the reading. This is figure 5. The 2000 vernier scale line that lines up with the graduated line on the thimble is added to the reading. In this case, 0.006 mm must be added. So this is figure 6. So the reading of the vernier metric micrometer is accomplished by adding the whole millimeters, the half millimeter, and the hundredths of a millimeter, just as before. To this reading is added the number of the 2000 of a millimeter, which is read of the vernier scale. So in figure 5. So 15 is the whole divisions are uncovered. It is equal to 15 millimeters. 1 to 0.50 millimeters division is uncovered. It is equal to 0.5 millimeters. 8 to 0.01 millimeter divisions line up on the thimble is equal to 0.08 millimeters. 4. The vernier divisions line up on the vernier scale is equal to 0.004. So in this figure 6, the metric micrometer reading is equal to 15.584 millimeters. So let's proceed to the example on how we are going to read the vernier micrometer. So let us start first the sleeve, followed by the thimble, and then the vernier. So the sleeve reading for this is 5.5 mm. The thimble reading is 0.28 mm. The vernier reading is equal to 0.004 mm. So the total reading for this is equal to 5.784 mm. Example number 2. So the sleeve reading for this is 5.500 mm. The thimble reading is 0.290 mm. The vernier reading for this is 0.006 mm. So the total reading for this example is 5.796 mm. And now let us proceed to the last example. Okay, so the sleeve reading for this example number 3 is 10.500 mm. The thimble reading is 0.340 mm. The vernier reading is 0.004 mm. Okay, so the total reading for this is equal to 10.844 mm. Okay, class. So now we're done discussing those reading. I hope class you learned something today about micrometer, which is my discussion, the parts and function of it, the metric reading, and then the vernier micrometer reading. Okay, class, that's all. Thank you and have a great day. Bye bye.